Hi all, welcome to today's session. In today's session, we are taking a new chapter under NCERT Mathematics, Grade 12. So the chapter name is Continuity and Differentiability. So yes, as such, I will be discussing only the exercise problems because the known factors example problems has its own solutions over there and they have been explained even more in a better manner. If there is any doubt, please do comment in the comment window. Let's get started. So we are going with exercise 5.1. Okay, so our first question reads like this: prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3, and at x is equal to 5. Yes, so we are supposed to prove that this function f of x is continuous at x is equal to 0, x is equal to minus 3, and x is equal to 5. Let us see the solution. First, we are supposed to write the given function. Given function is f of x equals 5x minus 3. Let us check for the continuity at x equals 0. Okay, so limit as x tends to 0, f of x is equal to limit of 5x minus 3 as x tends to 0. So 5 into 0 minus 3, which is equal to minus 3. Again, f of 0 is equal to 5 into 0 minus 3, which is equal to minus 3, as limit as x tends to 0 of f of x is equal to f of 0. Therefore, f of x is continuous at x equals 0. We are done with checking the condition for x equals 0. Next condition we have is x equals minus 3. Continuity at x equals minus 3. So limit of f of x as x tends to minus 3 is equal to limit of 5x minus 3 as x tends to minus 3, which is further equal to 5 into minus 3 minus 3, which is equal to 5 3s are minus 15 minus 3 equals minus 18. And f of minus 3 is equal to 5 into minus 3 minus 3 is equal to minus 18. As limit of f of x as x tends to minus 3 is equal to f of minus 3. Therefore, f of x is continuous at x equals minus 3. There's one more condition. Continuity at x equals 5. X equals 5. So limit of f of x as x tends to 5 is equal to limit of 5x minus 3 as x tends to 5 is equal to 5 into 5 minus 3. 5 into 5 is 25. 25 minus 3 is 22. Alright, then, and f of 5 is 5 into 5 minus 3 again, so it is again 22. So therefore limit of f of x as x tends to 5 is equal to f of 5. Therefore f of x is continuous at x equals 5. Yes. So when can we tell the functions are continuous? When limit of that function as x tends to a is equal to f of a, then when this condition is satisfied, no, we call the functions as continuous. We call the functions as continuous functions, right? Okay. We can move further with the second question. So the second question here reads like this: examine the continuity of the function f of x is equal to 2x square minus 1 at x is equal to 3. Yes guys, can you all do this? Those who can't, do follow this. First we are supposed to write the given function minus 1. Then we have to check continuity at x equals 3. Okay. So we have to take the limit of the function f of x as x tends to 3 is equal to limit of 2x square minus 1 as x tends to 3, which is nothing but 2 into 3 the whole square minus 1. 3 square is 9. Okay, 9 2s is 18. 18 minus 1 is 17. Right? Hopefully all of you have followed to you. Next, and f of 3 is 2 3 square minus 1. Again 3 square is 9. 9 2 times 9 is 18. 18 minus 1 is 17. Therefore limit of f of x as x tends to 3 is equal to f of 3. So f of x is continuous is at x equals 3. Again, what's the condition for continuity? Limit of f of x as x tends to a is equal to f of a. If this condition is satisfied, then the function is continuous. Clear? Yes. Next question. Next question. Question number 3. Examine the following function. Examine the following function for continuity. For continuity. Yes? Okay. So under that, the first function here is f of x equals x minus 5. Right. Solution. So yes, you have to first write the given function. Okay. Then we know that. What do we know? F is defined at every real number k. Real number k. And its value at k is k minus 5, right? In place of x, we are substituting by k. Okay. Also observe that limit of f of x as x tends to k is equal to limit of what's that function is x minus 5 as x tends to k, which is equal to k minus 5. Is this equal to f of k? Yes, this is equal to f of k. And then as limit as x tends to k of f of x equals f of k. What can we tell by this? F of x is continuous. F of x is continuous. Continuous at every real number. And it is a continuous function. And it's a continuous function, right? Yes. Similar way, we will take the second function. What is the second function? F of x equals 1 divided by x minus 5, and what's the one more condition given over there? X is not equal to 5. What happens if x is equal to 5? The function is infinity, right? 1 by 0 is infinity. It's not defined, right? Let's write the solution for this. Can you all try? Similar as the previous one. Okay. Yes. Okay. Let's write the given function first. Given function is f of x equals 1 divided by x minus 5, and x is not equal to 5. For any number, okay, for any real number, for any real number k not equal to 5, we have what we have? We have limit of f of x as x tends to k. Okay, is equal to limit of 1 divided by x minus 5 as x tends to k is equal to 1 divided by k minus 5. Is this equal to f of k? Yes, this is equal to f of k. As limit of f of x as x tends to k equals f of k, what we can say? What can we conclude by this? F of x is continuous. F of x is continuous at x is equal to k. Right? Okay. And f is continuous function. F is a continuous function. Okay. So can we move ahead for the next function? So next function here we have here is f of x equals x square minus 25 divided by x plus 5, and in this case also we have a condition x not equal to minus 5. Yes kids, can you solve this? Solution says very simple. First, as it is given function, f of x equals x square minus 25 divided by x plus 5, x not equal to minus 5. Why I make this an habit of writing the given function is you miss out few numbers while you're copying step by step. So you just write it as such. That's your first step. Next, for any real number k, okay, let me take k or c. I'll take c now. For any real number c not equal to minus 5, we have what we have, limit of f of x as x tends to c is equal to limit of x square minus 25 divided by x plus 5 as x tends to c, which is equal to limit as x tends to c x plus 5 into x minus 5 divided by x plus 5. We can see one thing, your x plus 5 is your x plus 5 gets cancelled usually. So then limit as x tends to c of x minus 5 is equal to c minus 5. Alright, and also we have f of c is equal to c plus 5 into c minus 5 divided by c plus 5. Alright, the c plus 5 and the c plus 5 gets mutually cancelled, so henceforth we would have been left with c minus 5, and provided c is not equal to minus 5. Okay, yes. Then is this kind of satisfying the condition? limit of f of x as x tends to c is equal to f of c? Yes. So hence f is continuous at every point in the domain of f, and therefore it is a continuous function. Therefore it's a continuous function. Fine. Alright, we can go ahead with the next function. Hopefully you're pausing the video here and there and copying down the notes. Okay? If you want, you can just make sure the speed is reduced. Playback speed. F of x is equal to mod of x minus 5. Okay. Is modulus function continuous? Okay. Is it continuous? We will see. We will see. I can hear you people telling modulus function is continuous, but it's not differentiable. Why so? We will take it while we are coming at differentiability. Right? Alright. So the given function here is okay, f of x. F of x here is mod of x minus 5. So it has two different branches values. One is 5 minus x and one more is x minus 5. Alright. Why 5 minus x? If x is less than 5, then it is 5 minus x. If x is greater than 5, or rather if it is equal to 5 also, it is x minus 5 itself. So this function f is defined at all the points of the real line. Is it actually defined? So this we are considering it as an assumption. Okay? Then we will prove whether it is defining or not. Let C be a point on a real line. Then C less than 5 or C equal to 5 or C greater than 5. So we have three different cases over here. Let us consider the case 1. Case 1, C less than 5. Then f of c will be 5 minus c. Okay, we'll take the limits. Limit as x tends to c, f of c, or f of x rather, f of x is equal to limit as x tends to c, 5 minus x is equal to 5 minus c. Yes. So therefore, what can we tell? Limit as x tends to c of f of x is equal to f of c, right? So therefore, f is continuous at all real numbers. real numbers less than 5. At all the real numbers less than 5. This is with respect to the case 1. So we have the remaining 2 cases. Okay. Let me now consider case 2. Case 2, C is equal to 5. Then f of C will be f of 5, which is equal to 5 minus 5, which is equal to 0. Then what we have, limit as x tends to 5 minus limit as x tends to 5 minus, or rather what we can say, we have 2 options over here, LHL and RHL, right? Limit as x tends to 5 minus of f of x is equal to limit as x tends to 5 minus x, which is equal to 5 minus 5, which is equal to 0. This is one condition. Next, limit as x tends to 5 plus is f of x is equal to limit as x tends to 5 plus x minus 5. Again, it's 5 minus 5 itself, so 0. So what we can observe here, left hand limit and right hand limits are equal. So we can say limit as x tends to 5 minus of f of x is equal to limit as x tends to 5 plus of f of x, which is again equal to limit as x, which is equal to f of 5. Rather, x tends to c minus, in this place you can write it as c minus c plus f of c, right? Yes. So therefore, what we can say by this, f is continuous at x equal to 5, right? Yes. Next we have case 3, C greater than 5. Then if C is greater than 5, f of C will be, f of 5 will be C minus 5. Alright, so limit as x tends to C, f of x is equal to limit as x tends to C, x minus 5 is equal to C minus 5. So therefore, limit of f of x as x tends to C is equal to f of C. So what we can tell by this? What we can tell by this? F is continuous at x greater than 5. So all the 3 conditions, it's continuous. So henceforth, modulus function f of x is continuous at x greater than 5, x less than 5, or x equal to 5 also. Yes. Can we go with the next question? Question number 4. Question number 4 reads like this. Prove that the function f of x equals x bar it is continuous at x equal to n, where we have one more condition here, where n is a positive number. Positive number. Right? Okay. Let's go for the solution part. So as such, I follow this rule, right? First we have to write the given function. Given function is f of x equals x power n. So it is evident that f is defined at all positive integers. Integers in the sense the n, positive integers n, and its values at n is n to the power of n. Oh yeah. So how is it n to the power of n? In place of x, if you substitute n, it will become n to the power of n. So then, what we can say, limit as x tends to n of f of x is equal to limit as x tends to n of x to the power of n equal to n to the power of n. So henceforth, what can we tell? Limit as x tends to n of f of x equals f of n. Right? Isn't this the condition for continuous function? For a function to be set continuous, this is the major condition, right? Okay. So therefore f is continuous at n, where n is a positive integer, right? Yes, where n is a positive integer. Alright, can we go with the next question? Yes. So the next question reads like this. Question number 5 reads like this. Is the function f defined by f of x equals x at 5? It will be x if x is less or equal to 1. If x is greater than 1, it will be 5. We have to determine if this is continuous at x equals 0, and again at x equals 1, and again at x equals 2. So yeah, can we go for the solution? Yes. Can we go for the solution? Okay. As it is given function f is if less or equal to 1, if x greater than 1. Right? Okay. Now, the first thing we have to check is at x equals 0. What is it at x equals 0? It is evident that f is defined at 0 and its value at 0 is 0. Right? Then limit of f of x as x tends to 0 is equal to limit of x as x tends to 0 equals 0. So clearly what can we tell? Limit of f of x as x tends to 0 is equal to f of 0. So henceforth f of x is continuous at x equals 0. F is continuous at x equals 0. Right. Okay. We have one more condition at x equals 1. What is it at x equals 1? F is defined at 1 and its value at 1 is 1. At 1 is 1. So the left hand limit of the function f at x equals 1 is, what is the left hand limit? Limit as x tends to 1 minus from the left hand side of the f of x is equal to limit of x as x tends to 1 minus equals 1. This is the left hand limit. The right hand limit RHL of f at x is equal to 1 is, what's the right hand limit? So limit as x tends to 1 plus of f of x is equal to limit to 5 as x tends to 1 plus equals 5. It's a constant function, right? At x approaching from the right side, it will be 5. So therefore, what can we tell? Limit as x tends to 1 minus of f of x is not equal to limit as x tends to 1 plus of f of x. Right? So therefore, f is not continuous. F is not continuous at x equal to 1. Okay, it's very clear. F is not continuous at x equal to 1. Right. We will check with one more condition. At x equal to 2. They have asked this in question, so only I am checking. Okay. F is defined at 2 and its value at 2 is 5. Okay, so then limit of f of x as x tends to 2 is equal to limit of 5 as x tends to 2, which is equal to 5. Right? Okay. Then therefore we can tell limit of f of x as x tends to 2 is equal to f of 2. What does this condition mean ideally? Technical statement. It is continuous. right? So we can write the conclusion. F is continuous at x equal to 2. Right? Yes. Alright, we will stop today's session over here. We will discuss the remaining questions in the next session. Thank you. Have a nice day.